All right, I think we're just going to go ahead and get started. There was one more person we were waiting on if they're able to make it. Do keep in mind for everyone in the audience, this is being recorded and likely will be uploaded to YouTube and shared to other ham clubs to present at their own leisure. So if you have any objections to that, please feel free to let me know. But all right, let's get started. This is the NOVARS Packet Radio Crash Course. Going to give a little presentation talking about what packet radio is, what are some examples that we use today, some hardware and software requirements to get started, and then using a bulletin board system and WinLink with a live demonstration as well as a Q&A session at the end. In this mode on Discord, I am not able to unmute anybody to ask direct questions, so if you have any, feel free to post them in the meeting chat, and I will review them at the end when we have some time. So let's go ahead and get started. So what is packet radio? So packet radio is sending data over the radio via small organized bursts, also known as packets. This is the same way that your internet works to send and receive data, except that is using IP packets, and it's working at a layer 2 level. Usually those packets are also significantly larger than what we're using. The protocol ham radio is using is called AX25. It's been around since the late 70s, early 80s, and is still in use today. It was designed for hams to be able to include call sign and digipeater information for the packet to properly route across the network. And we will get into a little more of that later on in the presentation. So let's talk about what a packet is. All a packet is a burst of data. But within that burst of data, there are instructions that tell the next receiver where your data is going and how to handle the data that it is receiving. So for example's sake, if we send out a packet to connect to a BBS node, we have an instruction there that says, I'm looking for this BBS node. Here's the data I'm trying to send to it. There also may be some information within the packet about a digipeater acting like a middleman, and it will repeat the message for us so we can reach a BBS that's out of our direct range of radio frequency. Now, one big thing that a lot of people get confused with packet is packet speed. So AX25 in the United States is most frequently used at 1200 baud, also known as 1200 AFSK. That stands for audio frequency shift keying. There is another option for AX25 packets that's most commonly used, and that is 9600 baud. It's used, but much more sparingly. You do need some specialized hardware and pretty good conditions for it. Even across town, you can kind of have some difficulty with the audio being decoded since it is so sensitive to really any sort of interference on the frequency. It does, like I said, it requires some specialized hardware. You need to have a radio that can handle flat audio in and out with no discriminator, no preemphasis, no de-emphasis. There is a small number of radios that support that out of the box on the market today. They're usually a little more expensive. However, there are many modern radios that have APRS built into it that already have 9600 baud available on them. Usually just a menu setting will let you switch between the two speeds. And if you're ever in an area where there's 9600 baud traffic for APRS, you can experiment with that quite easily. However, in the United States, it is decently rare. Usually it's only found on UHF and up frequencies. The only large-scale system I know of is along the eastern seaboard, about from the southern point of Vermont almost down through Virginia. There is a 9600 baud backbone of APRS, digipeaters, and iGates that kind of follow along the Appalachian Mountains, and they use 9600 to interconnect with each other. Usually that's just for moving larger amounts of data quicker, but other than that, it's not really used in practice. Here in town, we did set up a 9600 baud node for APRS and packet that we can experiment with, which more on that later. But that is still in its infancy, so we'll have to see how it performs. So I did want to share this for anyone who has not heard what 1200 baud packet sounds like. This is a quick burst of 1200 packet from someone who is transmitting a APRS packet. So that quick burst, play it again here. Inside of it is including this green text. It might be a bit hard to see, but it's this person's call sign, where the destination is going to. It looks like it's actually going to the International Space Station is where he's intending for this to go. It also includes his location and a comment at the end. So all of that just came in that little quick, maybe half a second burst. And that really is the magic of packet radio. We can send data in just quick little bursts like that. Sorry about that. We can send data in quick little bursts, and depending on how much data we're trying to send, we can use different speeds to accomplish that. Now, what are a few examples of packet radio that we use today? Well, APRS. Almost everybody knows what APRS is who's in the hobby. That uses the AX25 protocol to send and receive messages, locations, and other information, just like we heard in that demonstration video. Less commonly today, but more in the past, bulletin board systems were a big use for packet radio. There are some DX clusters out there that use packet radio to connect to them. We host one of those as well. And then a newer method that's been coming around in the past maybe 15 years is IP over AX25. This is an experimental mode that combines protocols used for internet connection with AX25 on ham radio. So depending on the speeds that you have for AX25 connections, you can even download web pages. You can download files. There's even some experimental programs out there that let you do torrenting over the radio. Definitely some pretty cool stuff. It's just not really touched as much as it should be. And that's something we're hoping to change. Hardware and software. So packet radio can be done with any radio. And that asterisk is there for some more details that we'll get into. But that is true. If the radio has a microphone and a speaker, it can be used. Of course, some radios are going to be easier to do this with than others, but essentially if you can get audio in and out, you can do packet. I will say 1200 packet is really all you can do with this. You do definitely need specialized hardware for 96, but it's nothing that is too complicated. Hardware and software TNCs are going to be required, so this acts like a middleman. This is what sits between your radio and your computer and actually generates and decodes the AX25 packets. Hardware TNCs have been around since probably the late 70s. They're not really used as much today, but you can get new ones. Cantronics is still making some, I believe, and there are some other TNC variants out there, but the software TNC is much more well known. A great example is Direwolf. It is a free and open source software TNC that is cross-platform, works on just about anything. And that is definitely a good piece of software. The only other thing you'll need is a program to decode the packets, and that depends on what you're trying to do with packet radio. So a good example would be WinLink. WinLink is a program that amateurs use to send emails back and forth. If you have a packet WinLink connection that you're trying to make, you'll need your radio, you'll need some sort of TNC, whether it's hardware or software, and then an application to actually manage the email sending and receiving for you. On Windows, the most well-known is WinLink Express. There are a few others out there. PAT, which is a good cross-platform one that's popular with Linux users. WOAD is an Android app that is free and available to sideload. That works extremely well. And then I believe Radio Mail is available for iOS at a small cost, but it does work quite nicely. And let's say you want to connect to a BBS. You'll need a packet terminal software. Qt Term TCP is cross-platform. It is built by, I believe the call is GB8BPQ. He's the one who wrote LinBBQ, which is what most modern BBSs are running on. He has that program as well. Paracon, which is a Python-based cross-platform terminal. That's what we'll be using today for the demonstration. Linux CLI AX25 is built into the Linux kernel, and there are AX25 tools available for most distributions, so you can work AX25 packet right out of a Linux command line with a compatible TNC. EasyTerm is another one that's available. I don't know if that one is cross-platform or not. I believe it's Windows only. A little bit of an older program, but definitely a good contender to use. So let's talk about what a TNC actually it is. So it is a device that sits in between your, let's say, computer or mobile device and your radio and generates and decodes the packets. Now, like I said, hardware TNCs did come out first. They've been around forever. And the nice thing is, if you go to a hamfest or a garage sale and you find one, whether the device was made in 1989 or 2009, they essentially work the same. You will be able to make most connections without any issue. Doesn't matter how old the device is. There are several hardware TNCs that are still in production. Like I said, there is Cantronics. MobiLink has a Bluetooth one that has an interchangeable cable that can connect to many different radios. And the ones out there have a lot of different features on them, but not as common as software TNCs. Direwolf, again, is the most popular one, written by WB2OSZ. It is pretty much available on any device you have, even mobile devices. And it acts as the TNC so you can connect to the radio with a standard sound card and a program on your computer. Some radios do have built-in TNCs. You can connect to them usually through a USB connection or Bluetooth, and they work directly with your device. You do not need to run any sort of software TNC like Direwolf or have a hardware device in line. The radio takes care of everything for you. Now, one very important thing to note is a sound card is not a TNC, and a TNC is not a sound card. A sound card is just a device that transfers audio from your computer or mobile device to your radio. A TNC, however, is the specialized piece of software or hardware that actually works with AX25 packets. If you're looking into purchasing any hardware for this, you just need to keep an eye out for this difference. A lot of people, and I do this myself, I run just a normal sound card. A lot of people will use the signal links. I have a USB one that goes right into my radio, and then I use Direwolf as a software TNC. The reason for that is now I'm not locked to only one thing I can do with that sound card. I can use the same sound card for SSTV, FT8, other digital modes that are out there. If you buy just a specific TNC, you will only be able to use that with packet systems. So if you just want to do packet, it's a really good investment. You don't need to mess with getting a sound card and Direwolf or other software TNC to work together. The hardware TNC is just one good all-in-one solution. Works really well. Now, I did mention that you can run packet on any radio. Any radio you can get sound in and out of. This is very true. However, there's some easier options out there. A lot of HTs, like the one shown here, have a Kenwood-style connector. You can purchase inexpensive cards like this. This is called the AIOC, the all-in-one chip or all-in-one card, I believe it is. That plugs right into the side of the radio, and then the white and red cable plugged into the top is just a USB-C. So that acts as your sound card, and you can interface into your radio. Again, if you want to do packet, you'll need something like Direwolf to act as your software TNC. But with this as well, you can do other digital modes as well, say SSTV if you want. You can also build these. They are very, very simple devices. It's just a matter of getting sound in and out. A lot of people have built custom 3.5 and I believe 2.5 mil audio cables that go into a inexpensive $5 USB sound card from Amazon, and they work perfectly fine. This is just a little bit of a cleaner solution, especially if you're looking to have something that you can just throw in a pack and kind of set and forget. Now, with that, we should talk about radios that have APRS built into them. A lot of radios on the market have it, and these do technically do 1200 or sometimes 9600 baud packet, but they only work with APRS using the built-in program. There's only certain models out there that allow you to connect into that onboard TNC, or in this context, modem is used interchangeably. There's only a few devices that let you do that. Most of the offerings from Kenwood on their higher line HTs do allow this. I know the D72 does, as well as the D74. But let's say this Anytone here, for example, does not permit you to do that. So while you can do APRS, you will not be able to hook up you will not be able to have this radio directly do packet. However, you can still plug a sound card into the side of these radios because they have those Kenwood jacks, for example, And you can do it just like you would on the more inexpensive Chinese radios. Works just the same. It just doesn't have it built in. However, packet-ready radios, what I call these, pretty much any radio with a data port. You're going to find these more on base stations or mobiles. Shown here, I believe, is the back of an FTM 60 or something like that. That has a data port directly on it. Usually they're 6-pin DINs, sometimes they're proprietary 8 pins, and these interface with a sound card, say like a DigiRig or a SignalLink, or even a homemade one if you wish. You will still need to do a software TNC, but this works a lot nicer instead of having to go through the mic ports and the speaker ports and bring a bunch of cables around. Also, like I was talking about, radios with a Bluetooth TNC make this pretty much the easiest you can get. These will Bluetooth, say, right to your computer or your cell phone. You can launch the program that you want to use Packet with, and it just works. A example on the cheaper end of the scale is this VGC VR N76. I have one of these, and I only use it for Packet. I can Bluetooth it to my phone and use either APRS Droid for APRS or the WOAD software for WinLink and Packet Terminal to get into a BBS, which we will talk about. On the right side, on the higher end of the scale, this is a Kenwood THD75. Fantastic radio, quite expensive, but very nice. And this does also have a Bluetooth TNC in it. One difference to note between these as well, the VGC on the left only supports 1200 baud packet. The radio on the right, the Kenwood, will do 1200 or 96. And that is including the Bluetooth TNC and the built-in APRS. So 1200 is the most common you'll come across, but if you're in an area that has a lot of 96 and that's what you want to get into, you might be shelling out a little more money for it, but it's worth it. So what are some of the things that we can do with Packet in modern times, aside from APRS? The biggest one I've come across is WinLink. Well associated with Packet radio, WinLink will use many different protocols to accomplish sending email over the radio. A lot of people have used VARA for HF. PACTOR and RDOP are older standards that have been used on HF, VHF. Telnet is always a good option, and of course, Packet. For the purposes of this discussion, we're going to talk about Packet WinLink. Mostly you're going to find these nodes on VHF, UHF frequencies because they can permit better speeds due to the available bandwidth. So for example's sake, VARA HF without a paid license runs around 175 bit per second. Packet, you can have it run at 1200 or 9600 bit per second. Now, this is still really only good for text-only emails. If you need to download an image, you could be looking at several minutes of transmission to get that image in. So I'd still advise keeping it pretty basic to text-only emails, but it is a faster option than some of what's available on HF. Now with VARA HF, if you got a paid license, they do have proprietary software that can increase that throughput dramatically, but Packet is free and it just works. And it's a fun little mode to play with, especially on the higher bands. So I do want to take a moment here and just bring up WinLink Express on the screen here. So this is my WinLink Express here. This is a very familiar application to a lot of hams out there that are used to using it with, let's say, VARA HF, but we're going to open a Packet WinLink session. Now what this will do is I have been receiving some APRS signals as well, so that's why there's a lot of data here. However, this is going to act as my TNC. This is the program called Direwolf. It runs purely in command line. There is a configuration file that you will set up, usually just once, that has your call sign in it, your audio devices, and how you're PTTing the radio. If you happen to just catch this one pickup right here that is highlighted black, that is a packet it just received. That is actually one of our club members who is attempting to connect into the Packet node right now. And then this Packet node that we host also acts as an APRS iGate. So it just sent out a weather station from someone who's in the area. But let's take a look here and see what happens when I try and start a 1200 baud packet connection. On my other screen here, a small window that opened up asked me where I'm trying to send my packet to. We're going to use the call sign N0VRS and the SSID of 10. That is our WinLink server. So I'll drag this over here so we can see it, and you'll be able to see the raw packets on the left-hand side of the screen here, and you'll be able to see what WinLink is decoding when we make this connection. So let's go ahead and get started. And that's it. So in that whole process, I was able to connect into our packet node. Our packet node then reached out, if I can pull it up here, to this address here, which is part of the WinLink email backbone on the internet. Once it made its connection, it searched if I had any pending emails, any read receipts, anything sitting in my outbox, which I don't in this situation. Once it went through that check and realized I had nothing to send out, it then disconnected the session. And that's essentially what's over here. I'll be honest, I'm not 100% sure what these CMS commands mean. CMS is the mail server that's running on the packet node that the connections are made through. You can connect to CMS with raw command line and send these commands yourself. I just don't know how to do that, but WinLink Express takes care of it for me. Now, in that session, this all happened within 12 seconds. Now, a lot of times people who will use, let's say, VARA HF to accomplish the same thing, whether it's checking their emails and maybe not having anything to send out, that can take almost a minute and a half. Because with HF, the bandwidth is much smaller, so it can't transmit data as quickly. So definitely a nice thing when you have a packet VHF WinLink node around, especially in areas that don't have great cell signal, or I've seen it in the Northeast with people who go out backwoods hiking. It just provides them another way to stay connected. So let's pop back into the presentation here. And let's move on to the big one, the reason that everybody's here. Bulletin board systems. This is what most people think of when they hear the phrase packet radio. So a history on bulletin board systems. Back in the 1970s and 80s, these were everywhere, especially in the 80s. This is what the internet was before the World Wide Web was invented and introduced in 1991. This is where people would post messages to each other. This is what was around before email. They would have chat rooms, file transfers, and a lot of them even hosted games. And this is well before web browsers existed. Netscape wasn't even a thing at this point. Now, these BBS systems on the internet were adapted to work on ham radio. Now, we can't send as much data as quickly over ham radio links versus the internet. You know, on standard, we're talking 1200 baud, and these could be going up to 56K. So what we use them for is essentially a store and forward messaging system. We can also use this to have long-distance message relays via digipeaters and other nodes. This is a good example of how you'd get email before email was a thing. You would put a message to your BBS that was local, send it to another BBS that was far away, and all of these systems intermediate to each other knew how to route your message based on what was in the email and what they were able to hear on frequency. BBSs nowadays can support some light file transfers, and the chat rooms are definitely still a thing, and none of this needs internet connection. This can run completely independently of any sort of cellular or internet outage. I will say that we do rely on the internet in modern day. For users of BBS systems, they will reach out and link to other BBS systems through the internet, which is a much more reliable way of being able to get data processed between different nodes. So in Ohio, the Ohio Packet Network is the most popular system. They also have connections to systems that are well out of the region, some even worldwide. They work through a VPN system that will keep all of the nodes interconnected, and if they're not able to reach each other over RF, they can always go through the internet and messages route just as they would. So, what's on our BBS system? So, when I say BBS, that is a specific application, but it is also a general term for the packet node. So, on the packet node, we have a BBS, a store and forward messaging system. You can send and receive messages to other users on our BBS system or other ones that are all interlinked through the Ohio Packet Network. If we are trying to reach out to a further one that's not in the network, chances are that some node on the Ohio Packet Network knows how to get out to a different system, and your message can be sent just like how regular email is sent. We host a chat server. It allows any connected users to chat with each other, and we can also connect to other chat rooms that are hosted on the Ohio Packet Network. There is a packet net that is held, I believe, about once a month, and they all meet in a specific chat room of a BBS that is down by Columbus, Ohio. Everybody jumps in there, everyone says hi to each other. It's a lot of fun. We are also hosting a DX cluster. For those who don't know, a DX cluster is a spotting network. A lot of contests actually only allow you to use spotter networks if you're accessing it via telnet or over the air. So depending on the contest, this is a great resource to have because you're now getting your spots over RF and staying within the rules, even though this is connected to the internet at the node site. Coming up soon, something we've been working on for the past few days, a searchable text-only offline copy of the English Wikipedia site. Why? Well, just because we could. We think that'd be a lot of fun to just have that available at all times, internet free, just for the heck of it. We're also going to design a first aid guide for people and a first aid guide for pets that will be easily accessible as well. Looking to that more as an emergency communication situation where if we are lacking cellular connection, internet connection, and you need, some simple first aid instructions of maybe how to splint a leg if, God forbid, someone's leg breaks and it's not a emergent situation, there'll be some tips on there. Also things for pets as well if you're stuck in a snowstorm and emergency services might not be able to get there in time. Just a guide that'll be available. For our NOVARS members that are watching this, any suggestions for applications to host on the system we're always looking for. We can integrate pretty much just about anything, especially if it works in a text-only format, so always keeping an ear out for that kind of thing. So now the fun part, the demonstration of the BBS system. So a few things I want to talk about and then a few things I'm going to show you. So the radio system. I don't have a way to show this with a camera at the moment. The radio I'm using is an FT897. It is a HF, VHF, UHF all-mode transceiver. Even if this was a simple Yaesu mobile, it doesn't matter. I'm connected through the 6-pin DIN connector on the back that's marked data. For the sound card, I'm using a simple USB sound card from, I believe it's XGG Comms. Relatively inexpensive. I think it was $60, $70. There are cheaper options out there. But let's look at the TNC setup. So I was mentioning that I was using Direwolf. I do want to quickly show what the configuration for Direwolf looks like, which is in this text document here. Start at the top. It is quite easy to go through when you first set this up. You'll come in here and you'll set what audio device you're using. You'll set what speed you want. For example's sake, if I want to use 9600, I'll just uncomment this line. And that's honestly pretty much it. Direwolf will work as an APRS, Digipeater, and iGate right out of the box, which is really nice if that's all you're trying to set up. But most importantly, it acts as what's called a KISS TNC. KISS actually means keep it simple, stupid. And that is a protocol that makes it very easy for programs to communicate with TNCs, whether they are hardware or software. So let's go back to the command line window here with Direwolf that's running. And if we scroll up here is where we made our WinLink connection a little while ago. And since we've been talking here, we've gotten several more APRS decodes from the iGate that's on the same frequency, which is also our iGate. And again, if you're just looking to decode APRS or even send APRS out of Direwolf directly, you absolutely can. Direwolf is pretty good at parsing APRS data and spitting out something that's easy for people to read. It also gives some little helpful tips if it's receiving packets that are a little off, or if you're sending out at too high of a volume. It takes care of all that for you. Most importantly, though, it acts as the KISS TNC. So we're going to take a look at this program called Paracon. I'm going to close out here, put this over to the right side. And Paracon is a Python program that is available on GitHub. It's completely open source and free. And it runs in Python. So if we run Python 3 Paracon, it will load this screen here. Now, when you first run this, it will guide you through a setup. It will ask for what's called an AGWPE server. Direwolf supports that as well out of the box. It's very similar to a KISS TNC, just a different protocol. So all you really have to do if you're running Direwolf on your computer locally is put in your call sign. Now, in this situation, my standard call sign with no SSID is being used on a weather station, and I don't want to put out multiple packets with the same call sign, but from different programs. So I have the SSID of 7. You can put pretty much whatever you want. I believe the standard max goes up to tab 15. Very similar to how you would set it up with APRS, depending if it's your HT, your mobile, things like that. Now from here, let's make our first connection. So I'll click on connect, and it's going to ask what I want to connect to. NOVARS N0VRS-7 is our packet node. That is the hub. We do have other direct SSIDs you can connect to. For example's sake, in WinLink, I don't want it to connect to the packet node and then have to open up the mail service. If I connect to N0VRS-10, that is directly into our RMS or mail server. Let's say I wanted to connect directly to chat. I know that's N0VRS-11. That's just what we set it for. But for simplicity's sake, I recommend most people just connect right to the central packet node. Make sure your call sign is correct, and we'll hit OK. We'll scroll down here, and we'll be able to watch the connection start. This is where it's doing a bit of negotiating. And here we've just gotten our connection that says, welcome. So on our node, if you type info, you'll be able to get some very basic information. In this program, all I have to do is just type and hit enter. This is all we have right now. This can always be expanded on. Every node you connect to will have a different info page. Always good to take a look at that. But let's take a look at our bulletin board system. So we'll type BBS and hit enter. From there, we can watch the packets over here. We've connected to the BBS. There's 456 messages, and the last one I've read up to is 410. Now, I can take a look at if there's any messages waiting for me. How do I do that? Well, LM, list message. I will say there is this help command. I do need to redo the help documentation, but it'll start spitting out all of the commands that we're able to do. So if this was your first time here, here's how you'd set your name on the server. Here's how you'd set your location by typing N and then your name, or Q and then your location. Here's some general commands here of how you can list whatever messages you have, read them, killing them, essentially deleting them. S call means send to a specific call sign. You can send messages to them, whether it's your friend who comes onto the same node, or if you use their full BBS address if they're on a different node. More on that to come later. And also, we need to talk about bulletins. So bulletin board system, we can post and read messages that are intended for everybody to see. So let's take a look at those quick. LB for list bulletin, hit enter. Okay, we have no bulletins on the system at the moment. If we did, we would see a bit of a different display. And it looks like I have no messages as well. So let's send a bulletin to get an example. So I'm going to say SB for send bulletin and then all. Once it receives that command, it's going to ask me, what do you want to title your bulletin? We'll say, hello everyone, and hit enter. Now, this is where we're going to put our text in. So we can put, hi everyone, doing a demonstration for the packet crash course. And if I hit enter, this doesn't necessarily post the message. I can continue typing. That just put in what's basically a line break. So I want to put /ex, like it says up here how to end it, end with /ex. That's what we will do. I don't trust the Control-Z method in this. I just do ex, and there we go. My new message that is posted now has a new number, it has an identifier, and it shows me how big the message is. So let's say I'm another user and I just logged on an hour later, and I want to see, oh, what bulletins are out there? I'll type in LB, and there's my bulletin that I put up. Now, how do I read that? We want to do R for read in 457. If you see at the beginning of the string here, 457 is the message number. This is the date it was posted, the size, the recipients, the sender, the title. So let's do R457. And there's our whole message. Here's the bulletin that everyone is able to see. So sending messages to individuals works exactly the same. We're going to pick on our friend here. So we're going to say S, and then his call sign is AD8AK. And we're going to say hello for the title. And we'll say sending a test message directly to you. 73s. Enter. And then we'll send /ex. And just like that, we now have a new message number, a new bid number, and the size. Now do keep in mind, even though we used 457 up here to read the bulletin, this message at 458 is directly for 88AK. He's the only one who can read it. Nobody else is going to be able to. When he logs into his mailbox and he types in LM for list any of the messages in his mailbox, he will see 458. In our case, we do not. Just like a normal email, it's only going to show up in his inbox. So that's the BBS system in a very, very basic nutshell. I am going to go through and rewrite the help documentation. If you're ever at a point in here that you're stuck, you can type in help or question mark, and it will spit out all the commands like we did up here. But let's go back to the node. So we're going to type in node and hit enter. Scroll down so this updates. And we're now back at the node. Now, we don't have the nice listing where it said BBS, chat, connect, so on and so forth. So what I usually like to do is type info again, especially if I'm on a node I'm not familiar with. This again spits out very basic information about the node. Let's go to chat. Let's take a look at the chat server we have. So now it says I'm connected to chat, and my name is Scott. I'm in East Findlay. And I put that as my name and my location, just like in the BBS. You can set your name and location in here separately. It does not correlate between the two apps. Now, if there was someone else in here, I'd be able to see their call sign. And if they put their name in their location in there, we'd be able to see it. Actually, just see one of our members just connected to the node right here. And he's going into chat. I just happen to see this through the monitor. And there he is. He just popped up. He's W8KJR. His name's Evan. And we are in the general chat right now. So at this point, we can just say, hi, Evan. That will send to the node, and then the node rebroadcasts it back out, almost like a store and forward machine, just much more instantaneous. Now, if we sit in here for a bit, there he goes. He just said, hello, Scott. I was able to hear that directly go into our node, but it didn't pop back up on our node until it rebroadcasted it. If you ever need help in this application, /help will bring up the help page. Putting a slash in front of any command you want to do will keep it from being parsed as a message you're trying to send. So there's a couple basic commands in here. /u will show you when there's anybody in here. It'll do the same block up here where it says my name or W8KJR's. You can run that at any time. Some other flags you can pass, like your name, your QTH, or your location. And another fun thing, too, is you can actually break this chat server into topics. This is just the topic general channel here. You can put as many topics as you want on here and have breakout chat rooms. And you can change to those as you please. There's also a few other nice little odds and ends in here. If you have a terminal program that supports color mode, such as this one, we can see what I've sent, what has been received. Other applications will actually split it out for who the sender and who the receiver is. So for W8KJR Evan, his would pop up in a completely different color from, let's say if our friend 88AK was in here, he could be green, Evan could be blue, I could be red. Nice little tool. It does say that it only works on BPQ term TCP, or QT term TCP. Those are programs that are available from the same person who wrote the BBS software that we're running here. I believe the programs are free. I don't know if they're open sourced, but they work really well. I just like Paracon here. That's just my personal preference. Other than that, a few other flags. You do have the option to send text to a specific station only. So let's say I had another person in here. We'll say 88AK again. And let's say I want to message just him and say /s 88AK, hi, give me a call. So if he was in here, only he would get that, and our friend Evan would not. He wouldn't be able to see it. But if we type anything in just the text bar here below with no slash, it will send right out to everybody. And we can see that happening down here on the left side of the screen. This purple that I'm highlighting is the message I just sent into the node. And the node knows that W8KJR is a registered user right now, so it's sending a copy of that packet to him directly. Let's say another user was in here, like our friend 88AK, there'd be another one of these lines with his call sign in it. And it would say, N10F said, how are you? That's how everyone in the same general channel is able to see it. The node knows who's registered within the system. Very basic rundown of the chat program here. We host a Thursday night packet net in here, 8 p.m. every Thursday, just for us in the NOVARS Club to just pop in and say hi. Anybody watches this who wants to connect to our node and jump in, more than welcome to as well. Now, let's do /b. /b is leaving the chat program and returning back to the node. There's a few more things I want to show you on here, and then we should be pretty much good to wrap it up and take a little bit of a Q&A. So where it says N10F *** left over here on the monitor window, that told Evan, who's still in the chat room, that I left. If 88AK was in there as well, he would get a copy of that said N10F left. And I'm back to the node. Now what I want to do is I'm going to say bye. Bye is the disconnect command. So that tells the node, all right, see you later. And the node closes the connection. But I also want to reconnect because I want to take a look at the screen you first get when you load up, which is this here. These are all the commands that you're able to pass right now. So I just want to talk about those really quick and what they are. BBS and chat we just looked at. Connect is how we're going to connect to another node. So if you know another node number, we can say connect or we can type just C, or we can put connect. We'll do connect. And let's say we know that this person is reachable over RF. We want to use port 2. How do we know what port 2 is? We'll get to that. But you just pick a port you want to go through, and then what node you want to connect to. Let's say, I don't know the node that's in Columbus, and I'm definitely out of RS reach for it, but let's say that was the node, COLUM-7. If I hit enter, the node will try and make a connection to that other node down in Columbus for me, and if I'm successful, I will usually receive a message that says connected to COLUM-7, welcome to the Columbus LinBBQ node, and then their commands that they can run. So what nodes are available? If I run nodes right now, this is going to take a minute. So I'm going to type this in and then start talking about a few other things. This is going to be a good example of where Packet has its limitations. If you look over on the left side and even in the monitor here, you can see it's starting to dump out a good list of nodes right now. However, there's, I think, 350 nodes within here that can be connected to. Pretty much every one of these is through the Ohio Packet Network, so it doesn't matter if we're in RF range or not. But we're only in the H's, and this has been going for 15, 20 seconds now. And it's not a lot of data. It really isn't. However, it's just the limitations of Packet. We can only send so much at a time with 1200. This is where if you have 9600 baud capable radios and you connect to this node, this list would be done by now. I believe in some testing last night that we did with 9600, we were able to receive this list in 5 seconds, all the way from A to Z. And you can see here, we're still in the N's, in the M's. Now, I did actually just see a node in here that would be a great example for this. The Modern Ham. He's someone who's been really pushing Packet radio in the modern age. He has a BBS and chat that is in this network, and we'll connect to his node. Now, if you notice too, I actually just got kicked off the node. It says disconnected. Well, I wonder why that happened. If we look here, every one of these bursts, these blue lines here that the node is sending to me, this pink is me telling the node back, okay, I didn't get this, but I got this, I got this. I didn't get this, but I got this, so on and so forth. With enough failures, the node might just give up. That does happen, and that's what happened here, where it just disconnected me. So, not a big deal. We'll connect again. This is a very large node list, so on 1200, it doesn't always work the best. Okay, so let's try that connect node real quick. We're going to go to MHNDE, who I know is the Modern Ham's node. So we're going to say connect. Port 6 is the port that we use to go out over the internet. MHNDE. You can put in their call sign as well, but these shortcode names are a lot easier, and the node knows what it is. Let's give that a try. Let's see if it goes. And just like that, I'm connected to the Modern Ham's node. I'm not 100% sure where he is. I believe he's somewhere in the middle of the country, but we're connected just over the internet. And he has very similar commands. BBS, chat, just like we have, and these programs work exactly the same because he's running this LinBBQ as well. So essentially the same commands that we talked about for either of these apps will work. The difference on his, he has RMS. RMS is that mail system that WinLink connects to. I took that off of our node just because in our use case, we're not really going to directly connect to it through a command line. We let a program handle it anyway. But let's go back to our node and just talk about a few last little things. So if I say bye, that's telling his node, okay, we're leaving. And then it tells our node we're leaving as well. And it disconnects us. So I believe, I don't know exactly for sure, I'd have to do a little bit of looking into it. It might be in the manual. Usually there is a command that allows you to return back to your node and stay connected to it. I just don't know what that is this time. But let's talk about a few other things in here. We'll tie it up on a last little fun one, which is DX. And we'll do a little Q&A session. So info, you've seen me run. That spits out what we have available on the node. This is something that a system operator of a node can update at any time. We have our nodes, which prints out this massive list of who you can connect to. Another important one, routes. So we'll give this a second to load here. And this is going to start spitting out who's available where. Now, I don't exactly understand how this works, to be honest with you, but what I use this for is these numbers. So on the left-hand side, this number 6, I know that's the port for the internet connection. So it's basically telling me it can see these nodes over this port. Here's the route distances. I don't use it too much. I usually use the nodes option. But let's take a look at ports. Ports is going to tell us what we have available to us. So on our system, we have 4 different ports that data can come in and out of. We have a telnet server, which I haven't opened up to the public yet, but if I'm at home and I want to go into the packet node, I can go through telnet. We have our VHF packet, 14501 megahertz. That's our 1200 baud packet. UHF packet is 445925. That's 9600. And the AX UDP hub, that is a name for the driver inland BBQ that uses the VPN connection for the Ohio packet network. So most of the nodes we're going to connect to, I'm going to put the number 6 before it because that's the port that I want to use. Show you users. Users gives a quick example of what system this is running. G8BPQ is the person who wrote this software. They're running this version on Linux, and the uplink I'm using is N10F-7. The last thing it's fun to take a look at is mHeard. This shows you who's been heard on the node. So what I want to say is mHeard2. Who's been heard on our VHF node? And this shows you who's been connecting to the system, how long ago they connected. So there's myself, N10F-7, and W8KJR. He jumped on 7 minutes ago to help us with our chat demonstration. There was me connecting from my straight call sign half an hour ago, and a few other calls in the area. Now, you sometimes get some weird ones. We had a 5GX call connect through RF 5 days ago. Don't know about that. It's possible, but I'm not sure. But then W3GV-5 186 days ago connected via these digipeaters and made it all the way here. These are just through RF. Part of it, too, is we're running APRS as well, so there could be some things coming in from that. We'll do an example of mHeard3, and we can see who's been using the 9600 baud packet system. Our friend 88AK got on 9600 19 hours ago. So that's a fun little list to see. You can run mHeard for port 6 as well. It's just going to spit out that it's essentially heard everybody at all times since you're connected through the internet. So let's take a look at the last program that we have on here at the moment, and that is our DX cluster. So we go to DX. This connects to the K3LR DX server through Telnet. If it's your first time connecting, it will ask what your name is. I've already been on here plenty of times, so I just pull this up and I leave it alone. Now you can see it's sending some rather large bits of data here because this is meant to be connected through Telnet on a computer. However, it still works perfectly fine on Packet. And then as people start to show up on the spotter networks, we'll just start to see them real time on the screen here. Very, very useful for contesting with contests that have restrictive spotting rules, especially if you're trying to find a specific state, location, country, so on and so forth. From there, we'll tell it bye. That command works on their Telnet server, or it should work on their Telnet server. There it goes, as it does on our packet node. So we said goodbye to him, and then we've disconnected from our node. And that is essentially all of the packet that we have to offer at the moment. Again, we are looking into doing some Wikipedia availability as well as some first aid guides, and there could be things further down the road as well. So let's head back to our presentation here. And just for fun, just want to show you what this ridiculous system looks like. We take a look at this server rack here. This is running in my basement. We have 3 hosts, a SAN, NVR, UPS, environmental sensor, switching, all sorts of fun stuff, completely overkill because the node is running on a tiny, tiny Raspberry Pi back here in the corner. That's all it is. This is our VHF radio running a 2980R at 80 watts. It's connected to our Raspberry Pi with an AIO-B, very similar to the card that we talked about earlier that goes into a Kenwood-style jack. It just has pads on it that you can solder your own cables to. Running a very similar setup over here. This is our 9600 baud radio, Motorola CDM 1550 at 25 watts. This one goes to a Direwolf instance running on a virtual machine down in the cluster, and then the Pi connects to that virtual machine over IP. And then outside here, we have our 17-foot antenna that's running both of these. There's a diplexer in line that allows both VHF and UHF to come in and out of the same antenna. And we've had pretty okay coverage for being about maybe 15 feet off the ground. It definitely takes care of it in town. So just want to throw that little fun bit in there. I am going to see about opening Discord over here. See if we have any questions in the chat or any hand raises. At the moment, it does not look like we do, which is fine. For anybody who rewatches this video or happens to watch it on another platform, any questions about this setup or any assistance I can provide if you're interested in running your own. Oh, I'm sorry. Looks like we have one of our members here who's requesting to speak. Let me go ahead and invite you. You have to forgive me. I'm not used to using this stage mode. All right. Dave, I think you're good to go.
Hey, I just wanted to say thank you for all you did to put this thing together. And I'm sure I'll have questions as I walk through it. Hey, thanks a lot.
Yeah, thank you, Dave. I really appreciate that. Yeah, like I said, any questions you might have, especially if this is your first time trying it out, any one of us in the server will be able to help you. Or if you have any specific questions that they may not know, feel free to send me a direct message.
All right, thanks.
All right, perfect. So I think that should just about wrap it up. Thank you for everybody who attended, and this meeting will be available as a recording on YouTube soonish, once I clean up a little bit of editing at the front and back. And yeah, I'm looking forward to hearing you guys on the air. Thanks for coming. We'll catch you all later.